Okay, so the average distance from the Earth to Moon is 3.844 times 10 to the 8th meters. The reason why we talk about average is the orbit of the Moon around Earth is not perfectly, it's not a perfect circle. It's a slight ellipse, and because of that, sometimes the Moon's a little bit closer, sometimes it's a little bit further away. But the average distance is 3.844 times 10 to the 8th meters. If the length of an average pencil is 1.8 times 10 to the negative 1 meter, approximately how many pencils would you need to would need to be connected together to reach the moon? Use appropriate decision in your answer. So about how many pencils is it going to take to do this? So before we get into that problem, I just want to kind of think through maybe a little bit simpler problem first. Let's say that we've got a yardstick, and I know that a yard contains 1, 2, 3 feet. So if the question was, hey, how many 1-foot rulers would it take to equal the length of a yardstick, right? Well, you could think about this. This is 3 feet, and then every single 1-foot ruler is 1 foot. So 3 divided by 1 tells you, oh, you're going to need 3 of these things. I just want to think about that because our total distance to the moon, right, is this number. That total distance is 3.844 times 10 to the 8th power. And I'm going to be dividing that number by, here it was 1 foot, right? This was 1 foot. But each one of these individual pencils is 1.8 times 10 to the negative 1 power. Now, obviously, it's going to take much, much more than 3 of these, but the division problem would tell me how many pencils I actually need. So I'm looking at 3.844 times 10 to the 8th divided by 1.8 times 10 to the negative first power. And if I look at this, probably the first thing I would like to do is go ahead and deal with this negative exponent, right? If I multiply this bottom number by 10 to the positive 1 and the top also by 10 to the positive 1, notice I am multiplying my original problem by 1, so I'm not changing its value. But I end up getting the number 1 on the bottom, right? 10 to the negative 1 times 10 to the first is 10 to the 0 power, which equals 1. And I get an extra power of 10 in my numerator. So if I was to simplify this, I now have 3.844 times 10 to the 9th power, and then my denominator is still 1.8. And if I do that division, I get, 3.844 divided by 1.8 is about 2.1. So this is about 2.1 times, 10 to the 9th power. So I would probably say, I'm just going to go with, I'll just say 2 times 10 to the 9th. I'll just round it times 2 times 10 to the 9th. So 2 times 10 to the 9th power. So what I need to do is I need to add a lot of zeros to that. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So if I look at this, I am looking at, that's 2 billion pencils. That's hundreds, hundred thousands, millions, billions. So about 2 pencils to reach the 2 billion pencils to reach the moon. So I'm asking you to contribute today to Project Pencil Moon. Bring your extra pencils into room 309, and eventually we will build a bridge to the moon with nothing more than pencils.